Hello guys, welcome to question 10 of our paper 2 exam preparation series. We are going to interact with some Euclidean geometry, but specifically proportionality theorem. Okay, let us take a look at the first question. Right, so we are given a diagram, okay, with three parallel lines, some triangles there definitely, and some ratios. AE over EB is 4 over 5, and 5 over 8 for FG over FB. Okay, first question, what are we looking for? AF over AC. So I always mark what I'm looking for like that, and definitely we can link it to the side, AE over AB, like that in triangle ABC. Okay, so what do we know? We know that AF over AC is equal to AE over AB. Remember, these are not lengths, we're given ratios. To introduce variables, 4 plus 5 becomes 9x. In any case, it's 4 over 9. Okay, and the reason for this statement is prop theorem. Okay, which lines are helping us to use it? EF is parallel to BC. Okay, so this takes care of the 2 marks in question A1. Right, good stuff. Let us look at the second question. All right, so in this question, we are asked to calculate the ratio HC over AF. So HC, okay, you can see in this triangle BFC, right? We can create proportionality there and link it to FG and GB. So 8 minus 5, that will be a 3 definitely. Okay, so HC over HF is equal to BG over GF, which is what? 3 over 5. Okay, but HF, when you introduce variables 3y and 5y there, right? And therefore we can find HC over HF is 5y, it's equal to 3 over 5, and therefore HC, when you multiply both sides by 5y, you get 3y. Okay, so we have HC, it's 3y, and AF, we had it from the previous question, that is 4y. Okay, so therefore HC over AF is equal to 3y over 4y, giving us 3 over 4. Okay, so this takes care of question 2. Right. Good stuff. So we are now going on to question B. All right, take a look. All right, so in this question, we are asked to prove that angle A1, which is the angle right there, is equal to 90 degrees minus E2 plus B1. Okay, so what can we see, or what information can we feel on the diagram? Okay, A is the center, so AD is the radius, AB is a radius, AC is also a radius. Okay, so angle at center theorem can apply here. So angle at center is 2 times angle at circumference. Angle at center is 2 times angle at circumference. And angle at center is 2 times angle at circumference. So we don't need to use all of those different ways, but we need to choose the one that will work for the required statement. Okay, so proof. Okay, what else can we say though? We are given a diameter DAB, a diameter will subtend a 90-degree angle the circumference, and that is where that guy comes from. Okay, and what else do we see? Okay, angles in same segment, cyclic quad. Angle D is equal to angle C1 plus C2. Don't need to talk about that there. And we know that angle E is equal to, angle E1 is equal to angle B1. Again, angles in same segment. So that's enough for now. Let us do this. Angle A1 is equal to 2 times angle what? Angle E1. Okay, you can choose angle E1 or B1, doesn't matter. Okay, so now what do we need to do? We know that the reason for this statement is angle at center is equal to 2 times angle at circumference. Okay, however, what do we know? Angle E1 is equal to angle B1. These are angles in same segment. Okay, so that guy will come in there. Therefore, angle A1 is equal to 2 times angle B1. All right. Do we have B1 there? Yes. However, we don't have 2 times B1. What can we do? We can write it like this: angle B1 plus angle B1, like that. Okay, so we have that. We just need to intelligently write this to look like that. How? Like this. Angle A1 is equal to, we bring this relationship back there, E1 plus B1, right? And then we bring in the 90-degree angle. We know that angle E1 plus angle E2 is equal to 90 degrees, is an angle in a semicircle, right? And therefore, angle E1 is equal to 90 degrees minus angle E2. Where will this go? Goes back there. And therefore, angle A1 is equal to 90 degrees minus angle E2 plus B1. B1 still remains where it was. Okay, did we prove the required statement? Yes. This was a very nice question. Right, there are alternate ways to have seen it or approached it, and I encourage you and challenge you to explore those ways. All right, so this takes care of question 10, guys, and we are now going to question 11. All right, thank you for tuning in. If you have not subscribed, ensure that you are subscribed and you're sharing this information and knowledge with your friends, family, and classmates, and ensuring that everybody achieves excellence in mathematics. All right, see you on the other side when I present question 11. Keep well. Sharp, sharp.